Okay, our final speaker in this section is one of our Google Summer of Code project folks. So I'd like to give a chance to Vaishnavi Gupta here to talk about extending the Python wrapper with tabulated thermodynamics and chemistry. So go ahead when you're ready.
Uh, good Good morning, everyone. I'm Vaishnavi Gupta, and currently I'm pursuing a BTech in Mechanical Engineering from IIT BHU Varanasi. And today I will be presenting my GSOC project on extending Python wrapper with tabulated thermodynamics and chemistry. Uh, so today here we are going to talk about basic motivation and the background for this project and the approach and methodology that I followed during this project, and a unit test case that I set up and the result that I got from. Right. Okay. So talking about what currently SU2 has, uh, right now SU2 uses the Python wrapper to couple its C++ code base with an external structural solver or any other software. So here we are gonna use this structure of Python wrapper and C++ code base along with a new library to make this code fast and flexible. And talking about the interpolation part, currently CP uses the trivialoidal map methods and multi-layer perceptrons to interpolate on the lookup tables and predict fluid. And so this is a very cumbersome process and is very computationally expensive. So in order to utilize the other interpolation methods out there like the SciPy KDP algorithm or any other Python library. Here we will be demonstrating how we have used the generic Python functions into our SU2 code and and demonstrate the linkage between them. Next slide. So in this project, the SU2 has we have linked the generic Python functions with SU2 that have been written in the Python wrapper, and this will help us bring the interpolation modules available out of the C++ language. For example, in Python, there are many modules available, so we will be able to use or any other functions, not just the interpolation modules, into the SU2 and our life can basic implementation. How I started with it was by first talking about 511 library. 511 library is a header only library that I chose to work with because it is really helpful in like creating a linkage between Python code base and the C++ code base because it enables both extending as well as amending of languages and modules. So the here Python in library added a submodule into it. If now we give the permission command enable 511 equals to during the build process. 511 will be added as a subproject to SU. Then we can leverage the functionalities of it. So next slide. It works like the Python wrapper is the solution Python, and we want to use that in the SU2 classes for fluid model class or any other. So we can use this Python 11 to create a module out of those C++ functions and import the same module in the Python wrapper and use those. Similarly, vice versa, like if there is a function in Python, we want to use that in C++, that can also be done by creating a Python binding mode. So next. So to demonstrate this, I have created a general test case where the problem statement is that we have to calculate different data variables in a specific. And there we actually there is a function which is calculating density as a from a user defined function, which in return is using a variable which cannot be easily calculated or is a very long process. So we have to interpolate it from a lookup table or anything. So in order to use Python, we write the file and then import that function into the class. We use those interpolated values and perform our further functions. So in this test field model class, number one, field model class has all the values of and one such function is the set td custom state function, which has which generates the following variable. And in this process, we need to use a record function. So this can be done by by using a Python binding, which will be created out of the Python function using 11 and like calculations are inside the one. Next. So in order to do this, we need to write, like we need to call the C++ function inside the Python wrapper file and then give that interpolation function of Python as a argument to that C++ function. So in order to import that C++ function into Python, we need to create a module that will be imported into the Python wrapper and the C++ function will be called. Similarly, if you want to call a Python function in C++, there will be a Python bind generated out of this and can be utilized in the C++ function. Next slide. If the interpolation function and other relevant values like density or any other data variable will be passed as arguments in the Python wrapper file to the C++ class via 511. There found other calculations will be done and the return until return a value which will be returned to the Python wrapper file. So in this way, the user can easily uh, perform the function without thinking about what is behind it. And, he or she will just that Python file and that's the result. I think give that. So we just need to run this command of Python 3.py and this whole functioning of going from Python to C++ again plus to Python will be performed and the result will be displayed by the Python priority. So during this project, like the challenges. So first challenge will be that wanted to that is available using 500, but it has it is connected with the wrapper files you to the PySU2 module. And the PySU2 module is written it contains various files, interface files. So some of the test cases use MPI 4.5 library to calculate to use several processors. So in order to be 511 module or a binding of we need to this I for uh, available in the delay and also this is a data size MPI 4 and it's not available in 512. So the major challenge was to pass this message to compact the 511 type of function. So due to this, we could not create a module the driver class to import that into Python file. So next slide. Yes. So we can create a there should be a universal function which can be used for most of the free functions. So in order to achieve this, we will be working on a MPI4 object creation, which can be easily called inside the Python 11, or a custom data type will be defined in Python 11 with of SU2 count type, and then it can easily create classes and which can be imported in the Python like a prompt to use the function defined in the C driver classes. And as told earlier, this big interface files are used in the PySU2, like the NumPy, the MPI4. These libraries have the interface files imported into them. So if I want to use Python 11 in similar way, I would have to write a Swig interface file and then easily be imported PySU2 and uh, so like come out number of PySU2. And error classes, thus with these config objects created with can easily be called by like using object. So that will be achieved only if the PySC2 and pivot table are linked. So this was like the future work I will be working on. And on a closing note, I would like to express my gratitude towards Eva and so for their invaluable guidance throughout the project. We would like to answer any questions.
Okay, thank you for the nice talk. We have some time for questions. So questions for the speaker.
Like, did everyone get about the functionality, or should I explain it to viewers?
I think you have one question. Why don't we let Nitish ask a question? I hope if you can't hear, let us know.
Yes. Sorry, I can't hear the question.
I'll repeat it for you. So he's asking, where can we find the software that you've developed? Is it on the repository somewhere in the SU2 project, or is it elsewhere?
No, it has not yet been pushed into that original SU2 repository. It is on my GitHub only now. For now, it is on my GitHub.
Will you have some time to wrap up the work and get it committed into the repository, or is the project officially done and you're on to other things?
Like I said, the future some integration is left, and after that, it will be merged into the original SU2 repository.
Great. Sounds good. Other questions? Okay, then let's thank the speaker again, and we'll take a break after this. So